Hello, and we're going to start lesson 1-2 today. All right, so lesson 1-2 is about solving inequalities. Just trying to get that to focus a little bit better. Okay, there we go. So first thing you're going to do is write an inequality that represents the sentence. So for number 1, we have 5 fewer than a number is at least 12. 5 fewer than a number is at least 12. So first thing we'll start with 5 fewer than. So 5 fewer than means that you are taking away from something else. What are you taking it from? You're taking it from a number. Oh, my apologies. But I turned off my phone. So first thing that we do is we have from a number. Now that number can be anything, but you want to think of a variable. So I'm going to go ahead and say x, and 5 fewer than that number would be x minus 5. Then we have at least 12. Okay, so some symbol and then 12. Okay, well, what does at least mean? So at least, think of it like you have to be at least this tall, or you have to spend at least this amount of money. So at least means at minimum, but you can be more. So 5 fewer than a number is at least 12. So at minimum, it is 12, but it could be more. So at least is greater than or equal. Let's try number 2. The quotient of a number and 12 is no more than 6. The quotient of a number and 12, so quotient means division. So a number and 12. So quotient is always written in the order of numerator, denominator. So a number would be numerator and 12 would be denominator. Is no more than 6. So I know 6 is on the other side, but what does no more mean? Okay, so you can have no more than 3 people in a room at a time, or you can have no more than 1 calculator on your desk. Okay, so no more means that that's the maximum. Okay, so therefore it's going to be less than or equal. Okay, is no more, it can't be more than 6. Okay, good. Let's go ahead and move on to solving inequalities. So we're going to solve each inequality, and we're going to graph the solution. And when we say graph, we are just talking about on a number line for right now. Number 3 is -3 times the quantity of 2x minus 5. Quantity plus 1 is greater than or equal to 4. So similar to how you're solving equations, you will solve inequalities. There are some things that you'll have to work with, and we'll talk about that in a sec. So the first thing you got to do is distribute. -6x plus 15. And the plus 1 doesn't mean to distribute. It would just be there by itself. Greater than or equal to 4. Then I'm going to combine like terms. And we get plus 16. Then I'm going to subtract 16. Negative 6x is greater than or equal to negative 12. And from here, we would divide by negative 6. And this is where one of those tricks come into play when you're working with inequalities. So when you divide, or sorry, when you multiply or divide, when you multiply or divide by a negative number, the sign changes. Okay? When you multiply or divide by a negative within inequalities, your sign changes. Okay? And when I mean changes, really it just means that it switches directions. Okay, so maybe switches would be a better way to say that versus changes. Okay, so when I say that, we have x and we have positive 2, but now rather than being greater than or equal, now it's going to be less than or equal. So we have our answer, but now we also need to do our graph. Okay, so I'm going to grab my ruler, make sure I have a nice even line. When you do your number lines, you need to have at minimum of 5 numbers. And when you label your 5 numbers, they should be evenly spaced and they should be appropriately numbered. So if, for example, you were going by 1s, you would all of a sudden change and go by 2s. So since I'm plotting the point 2, I'm going to say 2, 1, 0, 3, 4. Okay. The easiest trick to go by is using the number that you need in the middle and then have 2 more and 2 less. And from here, we have to plot our point. So is that going to be an open circle or a closed circle? Okay, hopefully you said closed circle. Okay. So remember that when you have greater than or less than symbols, you have an open circle. When you have greater than or less than or equal, you have a closed circle. And then last but not least, we have to determine which way my answers are going. So if x is less than or equal to 2, that means all my answers are less than or they are to the left. Okay, let's go ahead and try number 4. Two-thirds times the quantity, 2/3 times the quantity, x minus 12 is less than or equal to x plus 8. Okay, and so since we have to solve for x and there's an x on both sides, in this case we do need to distribute the 2/3. So 2/3 x, 2/3 of negative 12 is negative 8. I'm going to subtract my 2/3 x to the other side. Okay, well if this is 1x, 1 minus 2/3 is 1/3. And then subtract 8. Get negative 16 is less than or equal to 1/3 x. Okay, now we don't divide by fractions, so we multiply by the reciprocal. And so I get negative 48 is less than or equal to x. Well, on the last problem I said we should have switched the sign, But did we multiply or divide by a negative number? No. The number that we were multiplying to was negative, but not the number we were actually using, okay? And now you can write it like this, or you can switch it around. You just need to make sure that you rewrite it appropriately. So it was negative 48 is less than or x, so rewriting would be x is greater than or equal to negative 48. Okay, and go ahead and do my number line. Now, when you're working with negative numbers, you want to be careful because a lot of times students will mess up and change the order of the numbers. So remember, when they're negative, if you don't look at the sign, you think the numbers are going wrong, but remember, these numbers are technically bigger because they're closer to 0. Okay? And then we know that this should be a closed circle, and it should be going outward to the right. Okay, good. Let's try number 5. 3 bracket 4x minus the quantity 2x minus 7 parenthesis bracket is less than 2 parenthesis 3x minus 5. Okay, and I'm going to go ahead and challenge you to pause now and see how this comes out. Are you pausing? Are you doing it? Go ahead and do it. Okay, welcome back. Let's see what this problem should look like. So first we got to distribute within our parentheses. We get negative 2x plus 7. Okay, and then I'm going to go ahead and simplify on the left side, and I'm going to distribute on the right side at the same time. Actually, I'm going to wait till the next step to distribute. So then I get 6x plus 21 is less than 6x minus 10. And if I subtract the 6x, I end up with 21 is less than negative 10. Well, I don't have any variable to solve for because the variables cancel it out. So the question I guess I have to worry about is this a true statement or is this a false statement? Is 21 less than negative 10? No, that's false. So therefore, that means that it would be one of our special situations. Never, always, or sometimes true. So therefore, this would be never true. Okay. So to remind you about those, always, sometimes, never, true. Okay. They can happen with inequalities as well. Okay, so for example, 3 is always less than 6. Okay. Or 7 is always greater than or equal to 7. Okay, because of the equal sign. So this would always be true. Okay. Something that would never be true, negative 1 being greater than 2. Okay, a negative number is never going to be greater than a positive number. Okay, or 4 is greater than 10. Okay, those are never. And similar to how they were with equations, when you end up with a variable, x is greater than or equal to 8, x is less than 4, okay? That's going to be sometimes true. So always and never end up being numerical values, and sometimes are with variables. Okay? Go ahead and go to the next video for more notes.